Welcome to this channel. Myself Dr. T.N. DEBNATH. In the previous video, I have discussed the anemia and morphological classification. In this video, I will discuss the classification of anemia based on the etiology or based on the mechanism. Okay, so first of all, anemia classification based on the mechanism. So there are three important mechanisms by which anemia has described. Number one is the blood loss. Number two is the increased red cell destruction. We call it hemolysis. These are the heading. And number three is the decreased RBC production. So I will discuss the classification on these three heading. Decrease RBC production. So one by one I will discuss the mechanism and the example of these anemias. Okay, so first of all, let us discuss the blood loss. You know, the blood loss may be acute blood loss, or maybe chronic blood loss. In acute blood loss, where we get maximum, we will get in the road traffic accident. There will be acute loss of blood and leading to anemia. And in chronic, we will get in the GIT tract lesion, even GUT, genitourinary tract lesion, mostly the gynecological problem like menorrhagia and other problem will lead to chronic blood loss leading to anemia. So this is the first heading. So second heading we will discuss is the increased RBC destruction. So it is the increased RBC destruction. We call it hemolysis. So it has been described is the inherited genetic defect and acquired genetic defect. Okay, so what are the inherited genetic defect? If you discuss, so if you see, if it is the RBC, genetically we have problem in the RBC membrane. So what are the example of this defect in RBC membrane is the hereditary spherocytosis and hereditary eleptocytosis. This is the based on the RBC membrane. So RBC we have RBC have enzyme also. So RBC have enzyme. So there are two important enzyme. One is HMP shunt pathway enzyme. This enzyme deficiency and the glycolytic enzyme deficiency. They all are deficient. So HMP enzyme deficiency, what is the example? Example is G6PD deficiency and glutathione synthase deficiency. So this is the G and G for G6PD and G for glutathione synthase. What are the glycolytic enzyme deficiency? Glycolytic enzyme deficiency are the pyruvate kinase deficiency and hexokinase deficiency. So this is the PH. Remember, PH, P for pyruvate kinase, H for hexokinase. So this is the inherited genetic defect leading to anemia. Okay, so let me discuss the acquired genetic defect. Oh, there is another important inherited genetic defect. It is in the hemoglobin production. I will discuss it. So first of all is the membrane, second is the enzyme, third is the hemoglobin production. So see, in hemoglobin we know there is a globin chain. So if there is a decreased globin chain synthesis, we call it thalassemia. Example is thalassemia. Okay, but if there is a globin chain is there, but that is structurally abnormal. This is important. Structurally structurally abnormal we see in the sickle cell anemia. Remember, sickle cell, even the shape of the RBC is also like a sickle, we call it sickle cell anemia. So this is the based on inherited genetic defect. And acquired genetic defect, we know is the acquired genetic defect. If you discuss the acquired genetic defect is the PNH. We know paroxysmal nocturnal hemoglobinuria. We know it, paroxysmal nocturnal hemoglobinuria. It is because of deficiency in the phosphatidyl inositol linked glycoprotein. Okay, so we'll get the PNH. So this is the acquired genetic defect. Next point is the immune mediated destruction. Immune mediated destruction. Where immune mediated destruction? Immune destruction where we will get in case of Rh incompatibility. Okay, Rh incompatibility we get in the blood transfusion. So this is the immune mediated destruction of the RBC. Now there is a mechanical injury. Mechanical injury leads to hemolysis. Okay, what are these example we will discuss. Okay, number one is the MAHA, MAHA, MAHA. We know MAHA is the microangiopathic hemolytic anemia, and MAHA constitute HUS, hemolytic uremic syndrome, DIC, and TTP, thrombotic thrombocytopenic purpura. So this all will give you mechanical injury to the RBC leading to hemolysis, leading to anemia. Number two is the cardiac valve defect. Cardiac valve defect. If there is any cardiac valve defect, there will be mechanical trauma to RBC lysis. Okay, so there will be anemia, hemolysis, and anemia. And number three is the repetitive physical trauma. Repetitive physical trauma. We know in case of marathon running, we will get repetitive injury to the RBC, and bongo drumming, BONGODRUMMING, bongo drumming will get repetitive physical trauma. And we know there is mechanical injury trauma. So next is the any infection like malaria will give you hemolysis and anemia. Toxin related, any toxin like we remember as CSL. C is the clostridial toxin. S is the snake venom. L is the lead poisoning. That all will give you toxin related hemolysis leading to anemia. Okay. Number 4 is the sequestration of RBC, where there is a hypersplenism. There will be destruction of the RBC and leading to anemia. Okay, so this is based on the excessive destruction of the RBC leading to hemolysis, leading to anemia. So let me discuss the third point. Is there is a decreased RBC production. So decreased RBC production is based on the inherited genetic defect. Yes, there is inherited genetic defect. What it will do? It will deplete the stem cell maturation. Stem cell maturation is the Fanconi anemia. If you see the Fanconi anemia, there will be deficiency of the stem cell maturation. And erythroblast maturation defect. Okay, here we will get thalassemia syndrome. So this is based on the inherited genetic defect. We know there is a importance of nutrition also. So nutritional deficiency will also cause anemia. We know that vitamin B12 and folate is very, very important for DNA synthesis. If there is deficiency of the vitamin B12 and folate, there will be decrease or deficient of DNA synthesis leading to megaloblastic anemia. And there is hemoglobin production. We know it needs iron. If there is any iron deficiency anemia, IDA, there will be decreased formation of hemoglobin leading to anemia. So this is the inherited and nutritional deficiency. And third point is immune mediated, where there will be decreased RBC production. Immune mediated decreased RBC production is like aplastic anemia. Example is aplastic anemia, immune mediated. Now inflammatory is that we know in SED, anemia of chronic disease will cause inflammation leading to inflammatory damage leading to anemia. Number 3, erythropoietin deficiency. We know erythropoietin is very, very important for production of this one. So if there is erythropoietin deficiency, there will be anemia in case of renal failure. Even we see in case of anemia of chronic disease, there will be decreased erythropoietin leading to anemia. So there may be some primary malignancy of the hematopoietic cell. So it is a primary hematopoietic malignancy. We all know malignancy is a AML, acute leukemia. All acute leukemias will produce primary hematopoietic malignancy leading to anemia. And if there is a space occupying lesion in the marrow, bone marrow, okay, there will be decreased production of the RBC and leading to anemia. We see in case of metastasis. Okay, and infection, which is infection to the progenitor RBC cell. Okay, progenitor RBC cell leading to anemia. What is this infection? It is very, very important and has been asked in several times in exam. Is the parvovirus B19. This is very, very and last is the unknown mechanism. We call it unknown mechanism. We cannot describe the mechanism, but we have seen it is happen in case of severe acute liver disease or hepatocellular disease, So this is the full classification of the anemia based on the morphology I have discussed in the previous video. In this video I have discussed classification anemia based on the etiology or based on the mechanism. So if you know that much, it will be very much sufficient for your exam point of view, even for your knowledge also. And I have given it from the Robbins, and it has given very nicely in the Robbins. You can see in the Robbins in a single page it has given. So if you love the video, like the video, share the video and subscribe my channel. Thank you very much.